Okay, we're starting with the mother function. This mother function is what all other functions for square roots are built off of. If you get this, you will see its ripples in every other problem that we do today. So, starting off, the other class was kind of nice. They've already done some work for you. So, we have this table on the board, and this is what we use typically for the mother function. 0, 1, and 4. I use 0, 1, and 4 because I need to know the square root of a number. And if I take the square root of, for example, 2, my y-coordinate would be the square root of 2. I don't know about you, but none of us are graphing this. So, we don't use 2 because we don't want to take the square root of a nasty number. We use 1, 4, and 0. And we also could use 9, we could use 16, 25, all those other perfect squares. So I'm going to plug these in. And so you would look at something like the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. There's nothing too crazy that has happened yet. What's the square root of negative 1?
Negative.
I.
Oh,
right.
Nice.
We can't graph an imaginary number. So we are not going to use those numbers. So I'm not going to have negative 1, I'm not going to have negative 2, I'm not going to have negative 0.5. Basically, I have cut those x's off. I don't want to see them when I graph this. So let's plot our 3 points. 1, 2, 3, boom. Now I just said we can't have any negative numbers. So when you draw this curve, it goes like this. There is no arrow going in the other direction. It has a start. And so you need to find that starting point every single time. If you don't, and let's say I had graphed something like this, you are missing part of that graph, and I will mark it wrong. You always have to find this point. You always have to find that point right there.
Is it just 0, 0 every time?
No. Next piece about this. So we have our points here. Now, for the mother function, this always is our leading point here. Our domain is just 0 to infinity. Just like our last problem that we had looked at, 0 to infinity. And that's why I say it's a safe bet. Now you could also write this like this. You could write it as x is greater than or equal to 0. I don't like that for 2 reasons. One, you guys always mess up the inequalities. And I'm not trying to make you lose easy points. So I like the inequality, or the interval better. 2, you always mess up the x and the y as well. So like something, if you put a y there, that's wrong. And I take points. Where's the x or where's the y in the top part? There is none. So it's one less thing to remember. Now brackets, remember, are included. If you have infinity, it's never included. Range. What's my lowest point here? 0. And then it goes to infinity. So look at that. And my range I could also write as y is greater than or equal to 0, which again, I don't recommend. You don't have to write both. You just have to write one. So I do the interval. X and y intercept for this mother function.
This mother function, crazy.
I know. I was like, did I?
It's the mother function, that's right. So for this mother function, what is it?
Nicholas gonna be spamming that at tennis practice.
No. 0, 0.
Is that the end of it?
You a baby.
So this is our mother function. Everything is based off of it. Everything. All the graphs that we look at today will get connected back to this one right here. This one right here, Keisha. Now, folks, look at the board over there. You got 12-1, 12-1. No school. 12-2, 12-2. Honestly, you could do 2 lessons in 2 days to take the test.
Don't say that now.
With saying that, though, realize that you now have 2 days. You have an additional 2 days. You have, I'm going to say formative practice. I'm not even going to say a quiz. But you have all this extra opportunity. This test should be a slam dunk for a lot of you. Okay? It is what every semester we have one test that is like a GPA booster. That's this test. Pay attention, get this down, you'll be fine. Any questions on the mother function?
That's my new favorite vocab right there.
I already know you're gonna be spamming that at tennis tonight. I really should just throw in tennis.
I'm definitely not. All right, look at it. How did our mother function change?
It's a negative, so it's gonna be all imaginary now.
No, it's negative, so it is not happy. All right,
Womp womp.
but we are going to look at our x's. Now, if you think about order of operations here, I plug a number into x and I take the square root of it. Does the negative affect it for that first step? No. So I'm going to use the same points as my mother function. 0, 1, and 4. I'm not going to write down the y's. This negative right here is the same thing as a negative 1. So I got negative 1 times the square root of 0. Negative 1 times the square root of 1, and negative 1 times the square root of 4. So I get 0, negative 1, negative 2.
That makes sense, Nicholas. I understand now.
We are looking at 0, 0, 1, negative 1, and 4, negative 2. I draw this little arch, this curve, put my arrow on only one side, because again, I found the starting point. It does not go past that. That's my start. If I compare this to the mother function, it would look like this. It's just a reflection. That minus sign just means you have a reflection. It's the same thing when we had quadratics. If it was positive, smiley face. If it was negative, angry face. So it's just a mad mother function. Okay? Question? Okay.
Did you make up that term, or is that an actual?
Domain. If I'm looking at my domain, what is it?
0. 0 to negative infinity.
No, but you're close. 0 to infinity. So I start here and I go to the right. So that negative in front actually has no effect on my domain. That's something that we got to know. The range, well, that changed. Because now I'm looking at the highest point this graph will ever have, which is 0. What's my lowest point it's going to be?
Infinity.
Negative infinity. So I start at negative infinity and I go to 0. So that negative did change my range. It had some effect on it. And that's because we flipped it again. X-intercept, Y-intercept, same exact thing, 0, 0. So let's just write those in. Questions? Again, this is the same thing as your mother function, just flipped. Look at your next page.
Yeah,
So
it's
flip
hard.
on over to there.
Why is this lesson?
Jeez, there's only 2 lessons in the entire week.
Yeah, but each lesson's a mile long.
Oh my god.
Okay. You have done this before. You have seen actually what happens when you have a +3 outside of square root. Just a little bit different. Right here, this is vertex form. It is like the same idea, except applied to a square root. So that +3, do you think that +3 is going to take your mother function and go up 3, right 3, down 3, or left 3? Up 3. So our guess is that our starting point and all the other points from this mother function got pushed up 3. So we're going to try something else. So my mother function looks like this. 0, 0, 1, 1, 4, 2. If I take 3 and I add every single point to it, let's see what happens. So that point, I go up 3, that's at 4. This is at 2, so it's up at 5. Draw my curve. Now, this is a guess. This is Wendell's guess. Do we believe Wendell or find out?
You should.
when I take the square root of x, do I add 3 to the number and then take the square root, or do I just take the square root? I just take the square root. So it's the same other function points that we had. 0, 1, and 4.
Equals the infinity, so
Then you put those into that equation.
Yes. So I plug in the 0, plug in the 1, plug in the 4, and I put plus 3, plus 3, plus 3. So this is looking at 0 plus 3, and I get 3. And let's look at Wendell's point. 0, 3. So that one's good. I look at 1. I get square root of 1 is 1. Plus 1, plus 3 gives me 4. Second one's right. At this point, we're pretty dang close to saying it's right. That's 2. That's 5. We got it. So folks, there's 2 ways of doing this. When I look at these problems, some of you will like this method, and that's fine. Some of you are going to like what Wendell just did. He looked at it and was like, hey, it's plus 3. You can take your mother function and move all those points up. Both options are fine. You have plenty of time on the test to go through everything, okay? But both of them are fine. We're going to do a little bit more domain, range, x-intercept, y-intercept, then we're going to do one other thing. So domain, what is it? What? That is going to be our range. So the range has a height of 3 and it goes up to infinity. So that's good. Our domain is going to be 0, infinity. Now, really quickly, that plus 3, what did it affect? My domain or my range? It affected my range. So that means if the number is outside the square root, my range is going to change. So you are going to get to a point when you see that, and you can actually answer range and domain without even graphing it. Now, x-intercept. Where do I cross the x-axis? I don't. So there's none. Right? I never cross this. My mother function did, but my actual function does not. Y-intercept. 0, 3. No work required for that.
Nichols, I got that all right except the range.
Great job, Chase.
In
We're
that
so
one
proud of
lesson,
you.
you said mother functions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times.
We're not done.
He does like saying,
Nope. The yellow is just the mother function is not actually in this problem. I'm just showing you how it got shifted. Okay? You don't need that at all.
Nicholas, this next one changes the
Ooh, wow. Very good, Wendell. This next one does change your domain. But this is the tricky part. So you have x plus 2. When you had vertex form for a quadratic, I have x plus 2 right here. Does that shift me to the right or to the left?
left.
It,
I'm just taking a guess here.
let's find out. So it is going to change our domain. I'll put a little star there and a star up, or just underline that piece. Now, what number should we use for x? Give me one number to use for x.
9.
I'll use 9. Let's see what happens. So I use 9, and I get 9 plus 2 is 11. What's the square root of 11?
That's an awful number.
That's an awful number is right.
So don't need it.
I go. Negative 2 is the only one that I absolutely need. I need 3 points. I give you a little bit of wiggle room with the other 2 points, but I need negative 2. Because negative 2 plus that gives me 0. And this is my starting point. I always need to have that starting point. So we're going to graph that. So did I go right or left? I went left. Negative 2, 0.
See, I got
Right?
it right.
This drags me in the opposite direction, just like in vertex form. So we got that point. Now, what I will say is I'm really looking at just inside the square root, and I want 3 numbers to be under the square root. I want 0, 1, and 4. So if I minus 2 from all of those numbers, it gives me the number that I need for x. So I got negative 2. I take 1 minus 2, and I get negative 1. That's the other piece I'm going to look at, and our final number is going to be negative just 2. We plug these in. And we plot these points. Now, in purple, I'm going to graph the mother function, and we're going to just see how it translated. So I'd have these points, and this plus 2 drag this purple function 2 to the left. To drag every single one of those points over. So that's one connection I want you to see. Our domain. Where am I starting at for my axis? Negative 2. So that shows up right here, and it also shows right there. All right? It shows in the function as a trick because it's the opposite. It shows right here as my starting point. Okay? Now, the range. What's my range? 0, positive, infinity. And so the range did not change. It's the same as the mother function, right? It is not affected by what goes on inside the square root. X-intercept, negative 2, 0. Y-intercept. Caution. There's none in the table. But this is my y-axis. My green line crosses it, which means I have to find it. And folks, honestly, this is the easiest one to find. Because what do I do for a y-intercept? What do I know about one of my coordinates?
0.
0 for x. So I go here and I go 0 plus 2. Well, that's the square root of 2. So it's square root of 2. I just put the square root of 2 right there. And I'm done.
Lickety split.
Not that bad.
Should I put that for X?
0, 1, 2. What are those numbers increasing by? 1. 0, 1, 2. We're going to look at a pattern here. I look at the next one. 3, 4, 5. What's it increasing by? Here. 0, negative 1, negative 2. It's decreasing by 1. So let's just think about that really quick. This I told you was negative 1. 0 minus 1 is negative 1. Minus the 1 is negative 2. On this one, this is a 1. 1 plus 3, 1 plus 4, 1 plus 5. I could keep going on and on and on. If I choose my x's purposefully. If I put 5 right here, I can't do that. But if I go ahead and I put 9, then I can put 6. What are these numbers again? Perfect squares. So if I continue with perfect squares, I can increase by 1, or I can increase by whatever number is there. Just something for you to think about. I'm giving you a lot of connections, but I don't necessarily need you to memorize these things. You can plug numbers in your calculator, and honestly, you could guess and check most of the tests and still do all right. Now, what numbers should we use for x? Perfect. What other numbers? 1. What else?
4.
4. Okay. Now, you are going to find these numbers. Plug it in. Show a little work. Graph it. Okay. And then we're going to see if our graphs match. And then we will talk about domain, range, x-intercept, y-intercept, all of that fun stuff. I also have not graded your tests just because so many were gone yesterday. And I'm not even upset about that, so don't worry about that. But just get it done so next week we can hand it back. Okay? Next week, Wednesday, would be ideal. If you're done by then, we're fine.
Yo, Nichols, this one's harder.
It's
Oh,
different.
shoot. Oh, wait. I did it right, actually.
I'm going to put my numbers up there.
Never mind.
You take a look and see what you think about them.
Okay.
I'm also going to show you the mother function again, and we're going to make a comparison here and see how things are changed. Are we okay on getting the y coordinates? We got questions about that, or are we good? Okay. So you got 0, 2, 4. What number's in front of the square root? 2. So I go 0 plus 2 is 2. 2 plus 2 is 4. So pattern again, I got perfect squares lined up, so it works out. Now, the other thing, what is 0 doubled? 0. So that's why there's no change from the parent function to our function. When I look at the next one, this is 1, that's 2, that's doubled. When I look at this, this is 2, that's 4, that's doubled. So that's what's happening, it's a stretch. Okay? Now, domain. What's my domain? 0 to infinity. Yeah, it's the same as the mother function. When I look at my range, 0 to infinity. It is going to get to larger numbers quicker, but it's still getting to the same numbers. So 0 to infinity. X and Y intercept, what are they? 0, 0. Questions? All right. Putting it all together. Before we actually do the problem, let's dissect it a little bit. My starting point, it's not going to be at 0, 0. It's going to be up 2. And how far to the right or left?
Wait, hold on. There.
So, 1. So this is our stretch. Okay, so it doesn't actually shift us. So in terms of the shift, when I'm looking at a shift, these two things are shifting my starting point. So I'll tell you right off the bat that my starting point is right there. Don't write that down though. You don't get to write that down until we know to write that down, okay? So let's think about our x's now. I want to take the square root of 0, 1, and 4. If I go over to my problem, I think about order of operations. That 2 is not going to affect the square root until I actually have gone through and done the square root. The 3, the negative 3 I should say, doesn't either. So what minus 1 is 0? 1. Okay, so I put 1 right there. I will also use 2, and what's my final number? 5. And again, we're gonna actually write these out. So I'm gonna have negative 3, and I'm going to do 2 because the 0, 1 actually works out, I would say, the easiest. So I don't want to show you the easiest one. I want to show you one that's slightly harder. So I go 2 minus 1 and then plus 2. Step by step, let's do this. So I always deal with what's inside my square root first, leaving me with negative 3 square roots of 1 plus 2. This step is the step where people make mistakes. After this, we're normally good. Okay? Do I take the square root or do I multiply by 3? What? Oh, no. What? Multiply? PEMDAS. What comes first?
You square root first.
We square root it first, then we multiply. So it's PEMDAS. This is the point. Once we get past here, we're good. So this gives me 1 times negative 3 plus 2. The reason that works is because that's actually an exponent, right? The square root is the same as the 1/2 power. We got that in our last unit. So this gives me negative 3 plus 2, which gives me negative 1. That was our middle point. So what I want you to do is I want you to find the top and the bottom. Find those other 2 points. If you want to plug it in your calculator, that's fine. If you want to write it all out, that's fine. You just got to get good at whatever you're going to do. So try it. All right, folks. So we get 2, and we got negative 4. Now, let's check this out. There's lots of little checks there that you can do. What number is in front of my square root? Negative 3. I have perfect squares coming down, and I say perfect squares with air quotes because 2 and 5 are not perfect squares, but they make perfect squares inside. And so if I'm going down the list, I got 2, and then I minus 3, I get negative 1, I minus 3, and I get negative 4. So that checks out. So we have something that looks like this. And I draw my curve. My domain and range is going to be affected by those items. So let's figure out what they are. What's my domain going to be? Yeah, 1 to infinity. So remember, that's our horizontal. If it helps you, just actually draw a little arrow on the bottom of your graph to make that connection. I'm going from 1 to infinity. My start to my supposed stop. It doesn't actually stop, right? If I look at my range, I am going to look at, I have a stopping on top, but I don't stop on the bottom. So how do we write that?
2 to infinity.
Negative infinity to 2. Okay? Because we always start on the bottom. Always start with the lowest. So negative infinity to 2. If we're thinking those things though, that's good. All right? Don't get discouraged by that. X-intercept, y-intercept. We don't have one of them. Which one do we not have? We don't have the y-intercept. I got none. What do you know about an x-intercept? Y equals 0. Let's work through this puppy. So I'm going to start with 0 equals negative 3, square root of x minus 1 plus 2. First step, what is it? What do we? Yep, subtract 2. got -2 equals -3, x minus 1. Next step. We are going to divide by -3. I'm going to drag mine over here so I don't have to keep going down. That is going to be 2/3 equals the square root of x minus 1. Now, square both sides. Now when I square both sides, I get x minus 1. This is going to be 4/9. I square the top and the bottom. So your last step is to add 1. So if I add 1 over here, what's another way that I can write 1 that would help me out with this fraction? You do get 13/9. So instead of putting 1 here, I'm just going to put 9 over 9 because it's the same thing. And so that gives me 13/9 equals x. So that is our answer right there. Questions? Open up your packets.
Nichols, we should get snack breaks in that. Like in kindergarten, how they brought them up.
Do you want to go back to kindergarten?
If I go back to 10th grade, go back to
We probably should.
yeah, it's pretty damn good.
Square root of, what do we got for the first problem? We got x plus 1 minus 3. Let's talk about our x's. So I'm looking inside my square root. I take what's inside that square root, and I go x plus 1 equals the following numbers that I want. 0, 1, and 4. Again, I always need the 0. I could use 9 instead of 4 if I wanted, or instead of 1. But these are the easiest ones. I want you to find your x's. I want you to plug them in, get your y's. We're going to talk about it. I'll put a graph up there. We can talk about your domain range. I'll take any questions you got. And then you'll have time to finish hopefully 1 or 2 other problems. That's good.
Do we have to do the chapter 12?
Yep.
We don't?
You do.
Dang it.
Okay, what numbers do I got for my x's?
-1.
0.
Nice.
Oh, you did 0. Oh, shoot. I did 8.
You can do it.
And I did 3. 8 equals 0.
So your graph should look something like mine. Mine's obviously a pretty rough sketch, but something like that. Now, the 8, 0, that covers your x-intercept. Do I cross the y-axis? And where does that happen? 0, -2. Yeah, so that's what we got going on there. Now, domain and range. What's my domain going to be?
-1 to infinity.
Yes. Now, here is the deal. I'll say this one last time. If I would not choose this and I started with a different point, I would look at my graph and I could actually be wrong. Because if the starting point is, let's say, down here, or your domain is always going to be wrong if you don't start there. So that's why I always require that first point. So that is our domain. What's our range?
-3 to infinity.
All right. You have a couple minutes. Try to get 1 to 2 more done. All right. And I'll just be walking around. I can help out if you got any